Introduction. Humanity's eternal gaze. Since the beginning of time, humans have looked up at the stars in wonder. Ancient astronomers tracked constellations, sailors navigated oceans by starlight, and philosophers questioned the meaning of it all. The night sky has always been more than just a scattering of lights. It is a mirror reflecting our endless curiosity. Fast forward to the present, and humanity has built tools far beyond the imagination of our ancestors. We no longer rely solely on our eyes to study the heavens. We have telescopes, satellites, and observatories capable of reaching into the very bones of the universe. At the forefront of this exploration stands the James Webb Space Telescope, JWST, the most advanced observatory ever launched into space. More than a telescope, Webb is a time machine. Its infrared instruments allow us to peer billions of years into the past, capturing light that began its journey shortly after the Big Bang. With each observation, Webb is not just photographing the universe, it is rewriting the story of creation. A puzzle in the early universe. MAX 0647JD. One of Webb's first triumphs came with a revisit to MAX 0647JD, a distant galaxy first discovered by Hubble. At first glance, it appeared to be a faint, solitary light. But Webb's sharper vision revealed something more complex, the possibility of two galaxies merging. Using the natural magnifying effect of gravitational lensing, where the gravity of a massive cluster bends and amplifies light, scientists were able to study this galaxy in unprecedented detail. The discovery raised key questions. How did galaxies interact in their infancy? Were mergers a common way for them to grow? Webb's observations are helping astronomers piece together these cosmic puzzles. CEERS 93316. The universe's first light. Webb's power truly shone when it detected CEERS 93316, a galaxy whose light began its journey only 250 million years after the Big Bang. With a redshift of 16.7, it became one of the oldest and most distant galaxies ever recorded. This discovery gives us a window into the cosmic dark ages, a mysterious time when the first stars and galaxies flickered into existence. Studying galaxies like CEERS 93316 allows scientists to see how the first building blocks of the universe came together, turning darkness into light. And Webb may not stop there. It has the capability to push even closer to the Big Bang, possibly revealing galaxies from just 200 million years after creation. That would be like reading the very first chapter of the universe's story. Able 2744Y1. A stellar factory. Another milestone came with Able 2744Y1, a small galaxy located nearly 13 billion light-years away. Despite its size, just a fraction of the Milky Way, this galaxy is a star factory, creating new stars at 10 times the rate of our own galaxy. By combining data from Webb, Hubble, and Chandra, astronomers could witness how galaxies rapidly assembled during the universe's formative years. Able 2744Y1 is a reminder that size doesn't always dictate importance. Sometimes the smallest galaxies play the biggest roles in shaping cosmic history. GNZ 11 at the cosmic horizon. Among the most famous distant galaxies is GNZ 11, whose light began traveling when the universe was only 400 million years old. Due to the expansion of space, this galaxy is now estimated to be over 32 billion light-years away. It represents the edge of the observable universe, a boundary where our instruments reach their limit. Beyond it lies the unknown. It's like standing at the edge of a vast ocean, knowing that more lies beyond the horizon, but unable to see it. How big is the universe? This leads to a question that has fascinated scientists and dreamers alike. How big is the universe? The observable universe stretches about 46 billion light-years in every direction, but that may only be a fraction of reality. If space is curved, it could wrap around itself, creating a cosmos far larger than what we see. Some models even suggest the universe could be infinite, stretching endlessly beyond our reach. In this view, what we observe is just one small patch of a much grander, incomprehensible whole. The galaxy's web is capturing may represent only a tiny fragment of existence. Before the Big Bang, the theory of inflation, the Big Bang is often described as the beginning of everything. But modern physics asks a deeper question: what came before? The theory of cosmic inflation provides one possible answer. It suggests that in the first fraction of a second, before what we call the Big Bang, the universe underwent a period of unimaginable expansion. Space itself stretched at speeds far beyond the speed of light, not violating physics but carrying everything within it outward at a staggering rate. This inflation smoothed out the early universe, ironing out irregularities and creating the conditions that allowed stars, galaxies, and eventually life to form. Without it, the cosmos might have been chaotic, clumpy, and unrecognizable. If inflation is correct, then the universe we see today, the galaxies, the clusters, the filaments of cosmic structure, is just one tiny patch of a much greater whole. Some scientists believe inflation didn't happen just once. It may be happening repeatedly, creating countless universes, each with its own rules of physics. This bold concept is known as the multiverse. Imagine universes where gravity is weaker, where stars burn differently, or where life takes forms we cannot even imagine. The James Webb Space Telescope cannot prove the multiverse, but its discoveries of ancient galaxies, cosmic structures, and unexpected patterns may help refine these daring ideas. Galaxies, black holes, and the web of dark matter. As Webb peers into the depths of space, it's not just stars and galaxies that come into focus. It is also revealing the engines that shape them, supermassive black holes. At the center of nearly every large galaxy, including our own Milky Way, lies a black hole millions or even billions of times more massive than our Sun. These giants are not simply cosmic monsters consuming matter, they are architects. Their immense gravity sculpts galaxies, fueling the birth of stars, igniting jets of energy, and even determining how galaxies evolve over billions of years. Webb's infrared eyes are showing that these black holes may have formed earlier and grown faster than astronomers once believed. That discovery challenges long-held theories about the timeline of cosmic evolution. Did galaxies form first and then feed black holes? Or did black holes grow so quickly that they guided galaxies into existence? Alongside black holes is another enigma: dark matter. Invisible and undetectable directly, it outweighs ordinary matter by a factor of 5. We cannot see it, but its presence is undeniable. It acts as the scaffolding of the universe, holding galaxies together with its gravity, shaping cosmic filaments, and determining how matter clumps on the largest scales. By observing how the light of distant galaxies bends and distorts through gravitational lensing, Webb is helping scientists map this hidden cosmic web. Each new observation is like tracing the invisible threads of a vast tapestry that underlies everything we see. Exoplanets. Searching for other Earths beyond galaxies and black holes lies another realm of Webb's mission: exoplanets. These are planets orbiting stars far beyond our Sun, and Webb is already transforming our understanding of them. With its unmatched sensitivity, Webb can study the faint light filtering through an exoplanet's atmosphere as it passes in front of its star. That light carries signatures of the chemicals present: water vapor, carbon dioxide, methane, and more. For the first time in history, we can detect the fingerprints of alien worlds. Some exoplanets have scorching temperatures with clouds of metal and glass. Others are gas giants with storms larger than Earth itself. And some lie in the so-called habitable zone, where conditions might allow liquid water to exist. Already, Webb has revealed complex molecules in these atmospheres, proving that worlds beyond Earth are far more diverse and dynamic than we once imagined. Each discovery brings us closer to answering a question humanity has carried for millennia. Could another Earth be out there, hidden among the stars? Are we alone? This leads us to one of the most profound questions of all. Are we alone in the universe? With billions of galaxies, each containing billions of stars, the possibility of life beyond Earth is not just speculation, it's becoming a scientific expectation. Life may be rare, fragile, and difficult to detect, but in a universe of this scale, the odds tilt toward existence. Perhaps somewhere, light years away, another civilization is looking at their sky with instruments of their own. They may be asking the same question, wondering if they, too, are alone. If Webb, or a future mission, were to detect even the faintest hint of biology, whether microbial life on a distant exoplanet or chemical markers of civilization, the impact on humanity would be immeasurable. It would mean that life is not unique to Earth, but a natural consequence of the cosmos. The journey ahead in only a short span of time, the James Webb Space Telescope has already transformed astronomy. It has shown us galaxies forming in the dawn of time, black holes growing with astonishing speed, exoplanets with rich chemical atmospheres, and structures shaped by invisible dark matter.